Hello everyone and welcome to this live stream. Vinicius, I see you're in the chat already. I'm great, thank you for asking. So today's topic is about support and resistance identification Python. So guys, what I've prepared for you today is a quick update on our US 100 training bot that we have coded last week. And I'm going to show you some trade results that we have this week. And after that, I'm going to show you an app, that will identify support and resistance, and then we will code an animation tool to visualize support and resistance levels. So for today, I have prepared a very simple concept regarding support and resistance. So we're going to code using highs and lows. And as you've seen in the first, at the beginning of the stream, I have actually, shared this application that I prepared for you in advance, and we will have a look at it, how it works. And then over the course of the next live streams, we're going to improve it, backtest it, and hopefully we are going to create a new training bot very soon. So first, we're going to start with a quick update on our US1 training bot. So for those of you who haven't been here last stream, we have actually created a training bot, and you can find it in the previous presentation link. So what I'm going to show you here is just a quick slide from last week. And just a reminder, so what we have here is a strategy that is trading the momentum candle during US market opens, and then is trying to follow the momentum until the end of the trading session. So we have opened a trade on Monday and then yesterday, and unfortunately, so we started in a loss. So what you see, guys, here is my virtual private server, and what we have here is our Tickmill MetaTrader 5 platform, where we've opened 2 trades already. So you see here how our trading bot is running. And here on our live account, we have opened 2 trades. One has been opened Monday and one has been opened yesterday. So just to show the trades, I hope that you can see it. Let me just zoom this a bit bigger. So what we have here is the first trade, right? So here we have the first trade. The US market opened in a short position. Mo, welcome to the stream. Hi, thanks to have great to have you here. So we've opened a short position here. We got stopped out by the stop loss, and the second one we've opened here, and then it immediately reversed. So it's very unfortunate, but we're gonna keep the trading bot running. So far we are minus 14 euro, but as you know, right, trading consistency is a matter of months and years. So we can't let a single trade result affect our emotions and decisions. So my plan is to run this for several months and see how it goes. And I believe that the trading results currently have been tested. So maybe by the end of this week, I will increase the trading size to 0.5 contracts. Okay, all right, so this is the update for TradingBot. I'm planning to also release a live trading dashboard in the future, so you guys can observe the results every day live. But let's now continue with support and resistance. So let's now proceed to that. So apologies, just need a quick drink. So, support and resistance. Maybe what we could start with is show you the application that I've created, and then I'm going to show how I've coded it and how the logic works. Right, so here for today's stream, I have written a simple animation script that is going to visualize support and resistance. So I'm going to run this, and then we can check this in our application that I've created. So let's refresh this. So here, this application is processing candlestick bars and is identifying the support and resistance level. So it is a very simple script that is working with highs and lows, and how it works exactly, we will jump into Jupyter Notebook later. But what you can see here is it is taking the previous highs and lows from our candlesticks, and whenever a candle breaks out of that level, we are then checking for that breakout. So this currently just a simple indicator, but we see that yeah, it is generating signals. And this is, I think, a very nice way to actually understand what our script is doing, because if you just read everything from code, you are not able to fully understand what the trading bot is doing until you actually trade on live or you start visualizing the trading logic. Ganesh, welcome to the stream. Nice to have you here as well. Uh, and Ling, SIPS liquidity. I know what you mean by that, but yeah, thank you for joining the stream. So I guess you guys are interested in how the logic works and how I coded this dashboard. So we're gonna start with that. And once you guys fully grasp how this dashboard or visualizer works, we will then proceed to optimizing the indicators, the logic. Maybe as you know, highs and lows are not such reliable support resistances on its own. So we are going to improve that over time as well. So I've actually, off stream tried to find various methods to identify support and resistance, and I think we should start with the simplest one. And in general, how do you define support and resistance? And you define support and resistance simply by defining, zones where the market is likely to reverse. So when we touch this level, we expect the market to reverse, or when that zone is broken, we can treat it as a breakout signal. So it is a sign of weakness where we're trying, to capture the momentum of that breakout. And so this is how we define it. And it's actually, in my opinion, quite difficult to represent in code unless you have a clearly defined rule what support resistance is. So here in my Jupyter notebook, I have this notebook support resistance 2, where I'm going to work with highs and lows. And what we have here in this script is, let me just disable that for now. What we have here in this Jupyter notebook is, again, our simple imports where we are extracting OHLC data from MetaTrader 5. And so what I've done is I've extracted the open, high, low, close. And here, this is the historical data on EURUSD. And so a very simple way to identify support and resistance is you can simply check the previous highs and lows. So when you, for example, see something like, guys, a 52-week high has been broken, right? Or a monthly high and low has been broken. This is usually a very strong signal, that, this level has some significance. And we can actually do that by just checking the highs and lows for a specific period. So maybe what you see here is the support and resistance, which is defined as the high and low for a certain period, and I'm just taking the minimum or the maximum. So when we look at this example here, right? So this line here, for example, represents the maximum value for the past candles, which is actually this candle here. And then the support here represents the minimum value for a certain candle, which represents this candle here. And here you see that here all the values are representing retrospectively 10 candles below. And this is also represented in this application here, right? So basically, this is how we compute the first version of support and resistance. And now we're going to proceed to our application, right? That is actually trying to visualize the values sort of in real time. And what we have here, so let me actually start script again and see how this application works. So this application is extracting, again, OHLC data from MetaTrader 5, but we are feeding new candles with every interval update. So this basically is trying to show you the current state of market at this point in time. And I've added, these levels with these annotations. And when we have a breakout, this is a signal we want to generate. So I'm actually or foreshadowed the next strategy, and I'm trying to actually create a breakout strategy whenever this level is broken. And we need to do some back tests and see if it works. But I think that this has some potential. And for you guys, when we have a new strategy running, I think it would be very nice to have like a live trading dashboard where we would visualize these indicators, right? And so let's get into code. So how does this work? So the framework we're using in this case is Dash, and Dash is basically a web application package for Python, which is built on top of Flask. And to import Dash, all you have to do is using pip install Dash, and you can use these components to actually design your Dash application, right? And what we could do is, I already have this application done, so let's actually create SR animation 2, or maybe I can just get presentation. And we are going to code this application again. So we are trying to replicate what we have here and guide you step by step how to code this trading application. So let me actually just delete everything that we have here and start this application from scratch. So Dash Applications is again a web application. So what we can do is from Dash import Dash, right? So we are importing Dash, which is an object that is able to create our web app. And by calling app is equal dash name, we can create an application object, right? And using app.layout, we can specify the layout and the components of this application. Shimo just commented, hey dude, could you recommend accurate Git backtrader Python library? Well, now that you've asked, there are multiple libraries, and the ones I can recommend and that I've personally tested is Python backtester, and I'm going to add, backtesting. So it is this one. It is backtesting.py, and so I've personally used this one. You can check it out and try that for yourself. Other than that, I'm actually currently using my own backtester. So I have my own GitHub page where I have a ATJ Trading package, and in this package you can find your own backtesters as well, right? So I have in my past stream used this backtester and shown you how to use it, and maybe I could also share a video, with the access code to my backtester. So just give me a quick moment so I can share that with you. And so I think it's this stream. So I'm going to add my previous live streams, with my backtester. And also I think what would be interesting for you would be the GitHub page, right? So this GitHub page is full of, past live stream files where I've done some backtests, written trading bots. So I think all of that could be interesting for you. And then you ask, Pine script code in Python via AI chat will do this. So I'm not sure what you mean by that, but yeah, I haven't coded in PineScript before. I assume it's the programming language for TradingView, but yeah, no experience with that. So sorry, can't help with that. All right, let's get back to the layout, right? So yeah, we wanted to create a web application. So Dash has something called HTML components, right? So if you've coded in HTML before or have created a website in the past, you know that we can abstract this HTML using Dash. So I can create something like a div component, so html.div. And here I can create an HTML component. And if I want to create an h-on, which stands for a header, we can create our web application, right? As a text. And let's just run this application and see what that does. So if name is equal to main. Whoops. And we run the app using app.run. We can start this application, and 1 second. Oh, app.layout is equal to, apologies. And I've started the wrong application. Let me just close things I'm not using at the moment. So let me run this. And it seems that, 1 second. Oh, right, I see what the problem is. The problem is that I still have an old application running and it is firing some requests to the server. So let me just change the port to 8000. So my two applications I've created don't interfere with each other. So I'm going to run this on port 8000, which is a port that I haven't used yet. So by running this application, as you can see, I've created a web application that is not running, and we have an HTML component. So we still have a long way to go to get from there to what I've shown before. So here we have our web application, and as you know, we wanted to create something called support and resistance visualization. I think you write with Z. Please don't judge my English. And so we can restart the app simply, and then we can just refresh our page. And now you see, by changing the title, we now have an updated web app. So let's say we want to create an OHLC graph, and we want to display that graph on this web application, right? And you guys at this point maybe should know how to already create a figure, right? So if you look at our previous support and resistances, you know how to export the open, high, low, close, and you know how to create this OHLC fig. And if you don't know, don't worry about that, because we can simply just copy some functions from our ATJ Trading package. And here, what we're going to import is get OHLC history and create price figure, right? And how it works is that we just need to retrieve some historical data from MetaTrader 5. And so we're just going to copy these things into our application. And so what do we need? So we need the historical data, and to get the historical data, we first need to import some other libraries, which is import MetaTrader 5 as MT5 to connect to MT5, and we import datetime. So from datetime, import datetime. Great. So now we've imported datetime, and we are able to retrieve our OHLC data. So here, get OHLC history will get us the OHLC data. Let me just print that. And now we are just going to check if we are retrieving our data from Tickmill, right? So we're now connected to our Tickmill platform. And we forgot one thing. Before we can extract the data, we of course need to connect to Tickmill, right? So here, as you can see, I have the initialize functions. So this part allows us to connect to the MetaTrader 5 platform, and also we need to import our MT5 credentials to connect to our trading platform. And to connect to our trading platform, we can just import the credentials from our configuration file. So this config in our project contains the login data for MetaTrader 5. So here I'm going to import the MT5 credentials, and now by running this, we should now be able to retrieve data from MT5. As you can see, we have successfully exported OHLC. And to create a price figure, right, all we need to do is use the create price fig function. And by putting in our OHLC data, we're able to create a figure. So price figure is equal to create price fig. we add in the OHS data, and this function takes care of the figure generation. And if you want to show what the figure looks like, we can just use fig.show, and we can run this again. And after that, this line will convert that OHS data set and now generate this figure. But the problem is that we have just created a figure using Plotly, but we want to embed this figure into our web application. And to do that, there is a very simple way to do it. So if you see in our layout, we can import another component from Dash, and it's called DCC. And DCC stands for Dash Core Components. So to add our chart that we've created, we can just add another component. And here we can use dcc.graph. And here in this graph, we need to add this parameter figure is equal to price figure, right? So let's restart that and now see what this will do. So I'm going to restart my application. And as you can see, guys, now we have generated an OHLC figure that is now being displayed on our web application. So this thing, if you want to share with your friends, put it online, put it publicly, this is what you can do. And hopefully by the end of the live stream or end of the week, once we have this web application done, I will create it publicly for you guys. So you can just, enter an URL, something like apps.atjtraders.com, and then you will be able to access this app and try it for yourself. Great, so we've created this figure. Let's say we want to, create it a bit higher, right? So maybe to fill the page a bit. So what we can do is we can also update the layout of this figure. So we can, for example, say figure.update layout. And if we say height is equal to 800, we are going to extend the height. And then doing that, we should be able to fill the blank space here that we have there. So I'm restarting that, and after restarting again, we see that we have made the figure higher, right? So here we have the OHS data on EURUSD, everything's quite good. So how do we create a chart that updates itself, right? So this is the complete history of EURUSD. How would we create a chart that would update, candle by candle? And to do that, actually, let me use one way that's not very elegant or not very efficient, but it is something that works. And considering the fact that we want to create something practical and not something perfect, I'm going to show you the simple way how to do it. And over time, we can always improve it. So let's just do what we can, to make it work. So there is a component which is called DCC interval, right? And what interval does is it is able to update our charts on a periodic basis. So I'm going to create an interval component with the ID interval. And then there is the property interval, which is set to how frequently you want to update the application. So we set interval is equal to 1000. It will update every 1 second. So this value represents the milliseconds. And then there is a property called intervals equals zeros. This is basically the number of intervals counted. And just to show you in code what it actually does is I will create something that's called a callback in Dash. So callback is nothing more than a function that is able to listen to certain events and then update certain components based on the inputs. So I will create a callback using app.callback. And now, as you can see, there are output and input components, which I'm going to import. And our output is interval, right, which is the ID interval, and we want to listen, this is the input. We want to listen to the interval components, and our output is our graph here. So I'm going to assign an ID to our DCC graph. So let's call this price figure. And what we want to update here is the figure property, right? So we're going to update the figure with every update. So I'm going to create a function, define update figure, and here I'm just using the input intervals. So I'm just going to print n intervals, right? And I'm going to show you what this actually does. So I'm going to refresh this, and I'm gonna check this application again. Let's refresh this. And what you can see here is, 1 second. So let me restart the application one more time. Okay, I think my server is a bit lagging, but let me try one more time. So here, this is our application, support and resistance. And I believe that I have a mistake because my interval component is not updating, right? Because what I want to make is, okay, every time the interval component fires a request, it should, print an interval. And so I'm going to try to see where I made the mistake. So input is interval. Okay, so this is our graph with the ID price figure, with the component figure, and here we have an input with interval. I think I've created a list here, which is so ID is interval. That's our input. Oh, and the input here is actually the number of intervals, figure. Let me actually check what I've done in my previous script so I can compare the things here. So I've called one component OHLC fig, interval and intervals, OHLC fig, and then here is the figure. All right, so I see what the issue might be. So issue might be that I have actually, I'm going to remove this figure here, and I'm gonna return something empty. So for now, let's skip the generation of the price figure. Let's restart, and hopefully it will work now. All right, so this web server has been restarted. Dash is now running. And ID here is price figure. All right, we're terminating that. Okay, let's click on this one more time. So guys, this seems to be very strange. I'm still hoping to find the issue with the interval component. Maybe what I'm just gonna do is I'm just gonna see if I made any typos. Because in my other script, right, if I run this, we see that the interval is working, and I'm just trying to figure out where the bug is, and it's actually pretty annoying because I can't find the bug, right? So let me just start here. So we have our layout, we have our interval component with the interval, and maybe let's check the components here again. Intervals 1000 and intervals is 0. If I copy that and copy that, this should be the same. And then we have the input with the interval, and then with the end intervals. No, never mind. So we see that the application is regularly updating. So I'd like to try one more time. And we're printing and intervals. So app.callback price figure, figure. I assume okay, maybe I should just change the port. To me it looks like everything's okay, and I have to restart my PyCharm. Because sometimes what can happen is that the server did not finish properly, and as a result, the app is not working either. Because as you see, my server is kind of stuck and it's not reacting to my previous things. So I'm going to restart my PyCharm, and hopefully that would fix it. And let's just terminate everything and restart everything. All right, so we can actually try again and hope that we're not gonna have these issues again. Also going to open my task manager just to check if there are any unclosed Python scripts, and then we're going to see. All right. So I'm going to run the SR animation presentation. We are here at 0, and then we're refreshing again. And yeah, this is very strange. What I actually might try doing, okay, we have price figure and we output the figure. Let me just create a div component, and I'm gonna call this div component ID refresh test. So I'm just going to test if it works with other components. So what I'm going to do is I'm going to output test with the proper children and see if that works. We stop and rerun. Now we start the app, and for some reason this is working now, right? So what you can see is this interval component is now sending an interval update every second, and this is something that we can work with. So for example, if I return html.p and add a string representing the interval, and I restart this, what you will guys find is that this application, if I refresh it, this is the interval, right? So I'm able to update the application. Actually, let me make it bigger because HTML is quite small. I'm going to use H2. So let's refresh this. So you see that our application is updating every second, and we can now track these updates. So that is very good for us, as you know, we can use this update to update the charts every second. So now I have to now get back to the dcc.graph and try to update the figure here, and hopefully that would help us with the updates. So I think I might know the issue, right? So I think the issue is that I've predefined the price figure before, but I should actually create the price figure inside this component here. So what I'm going to do now to fix this issue is I'm going to create a price figure, and here I'm going to now plug in our price figure, and we want to update the figure component. We don't need this testing component for now, and let's run this and see if that works. And now we're returning a figure, right? So we return price figure. And there seems to be a bug, so let me check that. Callback function not found. A refresh test children. Perhaps you forgot to pretend the add. We have output, price figure, and we're returning price figure. Right now it seems to be running. Callback function not found. For output, refresh test children. The issue is that I cannot find refresh test because I have already updated the callback here. Oh, right, because what's happening is that our previous application or the browser was sending requests for non-existent components. So I didn't update that, so I actually had to refresh the browser. That was my mistake. So let's run this again, stop and rerun, and hopefully we should not receive any issues anymore. So now what we have here is we have our historical price chart, and I think, yeah, after some debugging and finding some issues, I think now I can actually start showing you how to create a self-updating chart. And what we have here is the OHLC data frame, right? So what I could try doing is maybe I could always display a subset of this OHLC data frame, right? So maybe new OHLC is equal to OHLC, and I can create a view of that data frame where I'm going to show you from this current update until 100 plus n intervals, right? So this would show you 0 to 100, 1 to 101, 102 to 2 to 102, and so on. So this would just show you a small subset of our OHLC data, or let's just do 50. And so instead of creating a figure, right, that is taking the entire data set, let's just always look at the current state at this point in time. So I'm already only displaying 50 candles as a result. And what you see here is, okay, I'm just showing you 50 candles. And in the next iteration of our update, we are displaying new candle, and then we are dropping the first candle. So what this is actually doing is we are just sort of running like simulating live candles. And this helps us with seeing the our backtests and our visualization at this point in time. So we've done that, and now let's proceed to creating the support and resistance, right, or the highs and lows. So I think at this point in time we shouldn't call it support and resistance, because I think that to identify support and resistance we should add some other metrics for confirmation. But let's calculate the high and low. Right, and to get the high and low, we can take this new data frame, and we can simply say, okay, new HLC high is, or let's just call resistance, right? And we're going to improve it later. So our resistance, or let's just call it just resistance, is equal to new HLC. We take the high, and then we take the maximum from that data frame, right? And our support is equal to our low, and we take the minimum. And what we can do here to actually display the resistance and support is to add a horizontal line. So we can take price figure and we can add a horizontal line, H line, right? And then we just set Y is equal to support, and we can add another thing, Y is equal to resistance, right? So if you rerun this, hopefully we should see new lines. And here you can see this white line here that represents the minimum and the maximum for this price chart. But you know, in the initial application showing you, the highs and lows were actually only restricted to, you know, some period, right? So what we can also do is maybe we don't want, you know, the highs and lows for this entire screen here, but only for last 10 or 20 candles. And to filter that, we can use tail, for example, and using tail, we just select the last 10 candles, for example. And let's do that and see how that would look. All right, so let's refresh this. And so now we see that we are only displaying the high and low for these candles, right? So we are always representing the last 10 candles. And what I'm going to do now is instead of using the horizontal line that shows across this entire chart, let's just look for, you know, the specified period that we want to analyze. And so what we can do is I'm just going to, you know, skip that, just copy a component here. And instead of using vertical line, there is something we can use, and we can just use add shape. So this is a bit more low-level programming. And so what I'm going to do here is I'm going to plug in the price figure that I have here. And what you can see here is that I have to specify x0, y0, x1, and y1. And then we also have, you know, the specification of our line dictionary, you know, the color, the size, and the type of the line. So here, instead, what I'm going to do is I'm going to set x0 to minus 11. So this is the 11th 11th value from the end, and then I'm going to use -1. And just to show you quickly how it would look, so I'm going to delete this and restart this. So let's refresh this, and here we see that I've created a support line that is following the last 10 candles, and it's visualized here and not across the entire vertical line. And so with this logic, we can create a second line that we call resistance. And here we would add the resistance. And by adding the resistance, we just create a new line that has different Y values, so it is higher than our support. So again, let's restart this. And what we have here, oh, I should also update the other value, which I'm going to do. And to update the other value, we need to also update the resistance value here for Y0. So I'm going to do that, and let's have a look here. As you can see, now we have our support resistance following only the last 10 candles. And now we are almost at the final part. How do we add text annotations for this application? And to use the text annotations, we can copy this part here. And what you see here is there is a method called add annotation, and we can just specify where the text should be, right? So our add annotation should be added with at the X value minus 11 at the resistance level, and we call this line resistance, right? And we're shifting the value 20 points above. So by running this again and restarting, so what we'll find is that we added a resistance text, right? So we're going to apply the same for the support line. So simply by just copying that, we're adding another annotation and we're calling this, we're setting the Y value to support. And here we're calling this support, and we're shifting this value below the Y shift. So we're shifting the text a little bit down. So by restarting this, we have the support line down here, right? So we have resistance and support. And so the last thing now is, in the previous script, I added a breakout. So we can create a very simple breakout logic. And this is what I'm also going to copy. And in this breakout logic, what I've added is this part here. And I'm going to copy that, and I'm going to explain what this thing does exactly. So if our last close price is above resistance, it is a sign that the price is broken above the resistance, and we add another text annotation breakout. Otherwise, if our close price, last close candle, is below our support level, it's also a breakout, and as a result, we are adding another text annotation and saying it's a breakout. So another restart, and let's have a look at this app again. So whenever the candle breaks above or below this level, we're hoping for a breakout annotation. And I see that I've actually made a mistake because I didn't implement the last close candle, so I should shift the results. Because what I've done here is I have actually displayed only the tail, right? So instead, what I should do is I should shift this by 1 and implement a high and low. Or I could actually take a slice and add minus 11 until minus 1. So the last candle would be disregarded, and that way we can check if the new candle is a breakout or not. So I'm going to restart that, and let's refresh this. And as you can see, whenever the candle breaks above or below, it will print breakout. See that? So I think this is actually pretty amazing. And maybe we can have a short look at this, how it's going to work. Sir, please explain how to draw fixed trend line and support height to lower side and high side to add trend line breakout logic. I think that's a very good question. And I think maybe I could try to create a script that is drawing a trend line. So you know what? I'm actually going to write it for my next stream topic. And we're going to discuss that on next stream after I've done some research, and I'm going to add the trend lines. So I think create a bot that detects trend lines. So thank you for a question, and I'll try to think of something that could be useful for you. All right, so I think we are getting slowly to the end of the stream, and so maybe just a quick summary. What we might do next is, with this new technology, I think we are going to visualize backtests so you can see more on the visual side how the trades are performing. And then we can also visualize or try to do some identification tools for support resistance, because right now we're just using the highs. And maybe what we could do is maybe try to check if there are multiple touches, right? Or check how dense or how narrow the support resistance is. And I've actually prepared some other analysis, but because we've already been streaming almost an hour, I think this deserves to be covered in the next live stream. So maybe I can just show you a quick walkthrough what I've done in the first support resistance, just to see what I've been working on. And so what I've been working on is a simple script that is actually calculating the number of touches for every level, right? So for example, here I've exported the OHLC data, and in this chart here, we're representing price levels. And for example, here, what this chart is showing is that how many times has the price level 175 been tested in the past. And as a result, the more you test the level, the more significant it becomes. So there's a higher chance of a reversal or a breakout. So I've been experimenting with that. And then I've been trying to visualize these levels on the price chart, right? So I'm not sure, how well it works yet, because I haven't backtested that. But if you look at my analysis of support and resistances, we see that this level looks quite solid. This one is also very interesting. We have a lot of dense levels here, and I think it's up to definition how we define those, and also we need to backtest these levels, how actually reliable they are for actual live trading. So I've done that. So I've tested some algorithms to represent support and resistances, but I think that it still requires some improvement. So what I've shown today is just a simple visualization of highs and lows, and maybe during another live stream we can check that. Great, so I'm just going to write down some topics for next time, and so what I can just edit here is I'm just going to just write some next topics. So I'm going to write the topic request from Ganesh at trendline detection, and then optimize the reliability of support and resistance. So I guess this is pretty much it for today's stream. So thank you guys for coming. If you have any other topics, please let me know, and I'll be back with another stream. Of course, I'm going to provide updates on my trading bot. So if there will be any new trades that are trading on our US1 momentum bot, I will update you on that. And throughout the week, I will also try to create new strategies. So you can stay tuned. And if there's nothing exciting going on, we're just going to work on these applications, dashboards, monitoring tools, and other strategies. So thank you very much, and see you guys next time. Bye bye.